Our last set of identities are half-angle identities. And tomorrow I'll show you how these come straight from the double angle cosine identities. But anyways, to use them, if we want tangent of 22.5, again, we have no idea what tangent of, or what the unit circle values at 22.5 would be. So instead of thinking about it like that, since I'm telling you to use half-angle identity, just multiply 22.5 times 2, and instead we can think of this as tangent of 45 degrees over 2. Whenever you're using a half-angle identity, all you need to do is double the value that you're trying to find, and that'll tell you what your theta is, or what your A is, in the identity equation. So now we just use this identity that was on the previous slide. We're going to just plug in sine of 45 over 1 plus cosine of 45. If you notice, there are multiple identities for half angle for tangent. First off, you won't have, this is the one identity we're not going to have you memorize because there's so many different kinds. And also, you will always be told which version to use for a problem if you need to do it. So now that we have this plugged in, we just go ahead and solve. Sine of 45 is root 2 over 2. Cosine of 45, 1 plus root 2 over 2. So now we can go ahead, combine these. 1 is the same as saying 2 over 2. So we have 2 over 2 plus root 2 over 2. So this turns into root 2 over 2 on top, 2 plus root 2, all over 2 on the bottom. Same as we've been doing this whole time. Go ahead and multiply by the reciprocal here. So we get root 2 over 2 on top times 2 over 2 plus root 2 on the bottom. Look to cancel first. These 2's cancel out. So root 2 on top, 2 plus root 2 on bottom. Lastly, we need to rationalize, so multiply by our conjugate. And now when we simplify this out, go ahead and distribute that in. And we get 2 root 2 minus 4 on top. On the bottom, we'll have 4 minus 2. 4 minus 2 is just 2. So now divide everything out. 2 divided by 2 is 1, so we're just left with the root 2. 4 divided by 2 is 2. And that's our tangent of 22.5 degrees. Okay, just like all of our other sets of identities, we can use these for exact values, or we can draw our triangles, use the formula. So in this case, we're given that sine of theta is 4/5, and that 180 less than theta less than 270. So we know that our theta is in quadrant 3. So we can go and draw our triangle. Quadrant 3, sine is opposite over hypotenuse. So now our formula for cosine of theta over 2. So we have plus or minus, and we're going to talk about that plus or minus in just a second. 1 plus cosine of theta all over 2. We use this triangle we just drew to find cosine of theta. If we do Pythagorean theorem, find that third side is negative 3/2. So this turns into plus or minus 1. Cosine would be negative 3 over 5, so minus 3 over 5. All over 2. And now, just like all the others, really the only complication in these is working through this math with all the fractions. So let's simplify this step by step. First, let's look at the top. 1 minus 3/5. Well, 1 is the same as saying 5 over 5. So that equals 2/5. And now it's all over 2. So bring that down here, plus or minus. Multiply by the reciprocal. Technically, this is 2 over 1. So we have 2/5 times 1/2, which gets us to plus or minus 2/10, which if we reduce that is plus or minus 1 over 5. Now, we need to go ahead and rationalize this denominator. So technically, this is plus or minus root 1 over root 5. Whenever you have a radical, you can separate it out. The square root of 1 is just 1, so we're at plus or minus 1 over root 5. Rationalize this for ourselves, root 5 over root 5. And we get that cosine of theta over 2 is plus or minus root 5 over 5. Now, This is the one tricky part where it's not just plug and chug. We should never actually have a plus or minus on our answer. We need to do the math to figure out where this angle would land. So keep in mind, we were given that our full theta is in quadrant 3. We're finding theta over 2 right now. So visually, we need to figure out where half of this angle would lie. Well, we know if we divide it in half, we just need to think mathematically, could it end up in quadrant 2 or quadrant 1? And mathematically, how to think about that. If we have that 180 is less than theta less than 270, let me switch colors. Essentially, if we're doing a half angle, think about dividing those by 2. If 180 less than theta less than 270, well, that means that 90 would be less than theta over 2, and then 270 divided by 2 is less than 135. So we know our half angle would be between 90 and 135. That is in quadrant 2. So that means our half angle will be in quadrant 2. We are finding cosine. Cosine is negative in quadrant 2. So that's the sign we are going with. And we will talk more about that tomorrow because I know that's the main confusing piece of these half angles beyond the plug and chug with the fractions.